Consider this problem statement. So here we are given this set S and it contains the element x, and x belongs to this interval that is 0 to 2 pi, such that x satisfies this particular equation, that is 8, and on the power of 8 we have 2 times sin x squared plus again 8, and in the power of 8 we are having 2 times cos x squared, that is equal to 16. So in that case we need to compute this particular expression, that is the number of elements present in set S plus sum of, so I will find sum of this particular term, and in x I will be substituting those values which are present in set S. So let us say if the set S contains elements like 1, 2, 3. So first of all for x I will substitute 1, then for x I will substitute 2, and then I will substitute 3 and take the summation, right? And after computation of the sub expression, whatever is the value, we need to compute the absolute value of that. Now first of all I will resolve this particular equation and get the number of solutions that are acceptable for x, and the reason behind that is that I can compute the number of elements present in set S. Now if you observe this equation, this cos x squared can be written as 1 minus sin x squared. So effectively this equation can be written as, I'll just put it over here, right, and this can be written as 2 times 2 minus 2 times sin x squared, right. Now in this case I'll consider substitution here, that is let a is equal to this, that is 8 to the power this quantity, right. So this is my assumption. Now I'll proceed ahead. So on doing this, the simplification procedure will be little easy. So this can be written as a plus, and this is nothing but 8 square, right, if you observe here this thing. So if I can just arrange this and write it again, so this one can be written as 8 square, that is subtraction to division, right, 8 square and 8 to the power, sorry, 8 to the power this quantity, that is 2 times sin x squared, right. So this can be written as 8 square, that is 64, and this one is already a, and this is equal to 16. Now on resolving this, definitely it is a quadratic equation. So this can be written as a square minus 16 times a plus 8 square is 64, that is equal to 0. On solving this, so if you can observe, this expression can be written as a minus 8 whole squared, that is equal to 0, and from this the only acceptable value for a would be 8, right. So this further implies that this value of a already I have considered as this is equal to 8. So that is nothing but 8 power 1. So from this we can say by comparison this exponent is equal to 1, and when I solve this one, if I solve this one, so from this we can say that sin x is equal to positive and negative 1 by 1 over square root of 2, when 1 over square root of 2, right, both for positive and negative. So since this is the given values that we got, the acceptable value for s, right, so set s, set s, or I can say the set which will satisfy this trigonometry equation, this will contain the values which are constrained by this particular interval, that is 0 to 2 pi, right. So what are the acceptable values for this, right. So the acceptable values would be, one will be pi over 4, that means x will belong to these values, right, these are the acceptable value for x, pi over 4, the next 3 pi over 4, the next one 5 pi over 4, and finally 7 pi over 4. Now outside this range I will not be going, because because the interval is strictly given as 0 to 2 pi, the interval 0 to 2 pi including 0 and 2 pi. So outside of 2 pi I cannot go, right. So from this we can say that the set S, the number of elements present in set S, that will be equal to 4. So this value is something that we got. Now we need to resolve this particular expression, right? So once we resolve this part, we can add both of this easily, right? So first of all, this is the equation that I'll be dealing with, the expression given here. Now let us resolve this expression step by step, right? So here, this is the given equation, sorry, the expression, not the equation. And now in the next step, I'll pick up all those values of S, right? All those values of X present in set S. But before doing that, I'll resolve this expression, right? Now here we are having secant, right? So this one, the secant can be written as 1 over cosine. So this can be written as 1 over cosine of this quantity, right? Cosine of this. And this cosecant can be written as 1 over sine of this, right? So now in the denominator we are having this cosine and sine with same angle, right? Now to converge this to one single trigonometric form, I can use the expression that is one of the identity of sine 2x, right? So here sine x is there, cos x is there, 2 is missing. So what I will be doing, I will multiply and divide the required number, right? So in this one, I can just merge this in together actually. So I'll multiply 2 and then divide by 2. So this is 2 sine x and then cosine of x, right? So we can just merge this out. So after replicating this particular step, so this one can be written as, sine of pi by 2 plus 4x, right? So this would be pi over 2, and here this would be 4x. So this is sine 2x essentially, right? Now once this part is resolved, so this one we can clearly observe that this is sine pi by 2 radian plus 4x. So this one again resolves to cosine 4x. This resolves to cosine of 4x. So this is how we have resolved it out. Now finally we'll just plug in the values one by one, right? So if I can write the set, so x can take the values, these are the values that x can accept, right? So now in the summation I'll just plug in the values, right? So this one, if I substitute pi over 4, this would clearly become cos pi, right? Similarly in the next one, this would be cosine of 3 pi, cosine of 3 pi. Now here next one would be cosine 5 pi, and then at last this is cosine 7 pi. Now so after resolving this, we can clearly observe that all these are ones, right? And here this can be written as negative 2 times 4, right? So these are all negative quantities, this 2 is outside, but this negative ones are added 4 times. So this is effectively negative 8, right? So 2 is the common factor, and then minus 1 I'll be getting 1, 2, 3, 4 times. So negative 4 times 2, that is negative 8. So finally I got this value as well. Now it's time to write the final answer. Now since we are having all the values, so this is given, or I'll just arrange it properly, right? So this is my given equation, sorry, given expression, and we need to compute the answer for this given expression. So number of elements in set S is something that we already know. So we have already computed that, right? So what is the value for number of elements present in set S? That is 4. So this one I will replace it by 4, and this particular expression we have resolved it and we got negative 8. Now 4 minus 8 is negative 4, but if I take the absolute value of negative 4, that is 4. So therefore 4 is the answer for this particular problem statement. The answer is 4. So using the trigonometric identities and quadratic equation, we have got this answer.